And also, will you guys shout if like my Wi-Fi dies? It has been giving me issues. But I think I may have fixed it.
Recording.
Yeah.
Because I'll have to drop off early.
Okay. So we've got 1 hour. Say again?
We're doing cameras again.
Yes, we are, Babesh.
Damn it.
Yeah, sorry, man. Geez, look at your camera angle. You can like see what your password is. Type your password. That's better. There we go. Oh, it's just Michael. Was it your birthday recently, Michael?
Yes, it was.
Happy birthday.
Thank you.
I saw it on Monday.com. I logged on this morning and it said it was Michael's birthday. And I'm like, who the fuck's Michael? Because there's like multiple Michaels. So I was guessing it must be yours. All right, awesome. So, what did we say we would do? Oh yeah, let me share my screen. So we said, I've done nothing, guys, once again, but I see that other people have done stuff, so that's good news. Actually on the wrong thingy there. Let's go code here, and I think we took some cool notes. Read me. Oh yeah. Okay, yeah. I actually did add something here. But I think we were talking about stuff, and then we said maybe we should, because the whole idea of this series or sessions or whatever you want to call them is really, and I don't think it must be just me either. So anyone who is keen to talk about functional stuff, like let's talk about functional stuff at least for just 1 hour a week, right? And let's talk about anything. I think in the functional world, I think I made the case last week that I think functional is worth learning. And look, like some more people came back, so maybe that means at least some people think that I'm right there. And so it was like, okay, we had a whole bunch of different options. We could learn about Haskell, and I think we must, but it's quite a horrible one. And PureScript also pretty horrible. Like it's a deep dive. And so actually, it was someone's suggestion. Who was it? Maybe Matt or someone. Maybe Chart said, what about starting with ELM? And it was like, great idea. Because I do know ELM. We have built some stuff with ELM. Matt is an expert in ELM. And in fact, Pulse is built with ELM, believe it or not. And it was a cool experience. It was a very cool experience. And we learned a lot, I think, using ELM. But we also did run out of, I think it did run out of like gas at some point, because you will see how simple ELM is as a language. It is incredibly simple, and you get to the point quite quickly where you go, wow, I wish I could do just a little bit more like this, a little bit more from the syntax perspective, and a little bit more from the language, and a bit more from, and it's a good place to get to that point where you go, it would be so much nicer if we could do this slightly other thing. And for me, that was when I flipped into PureScript. So I ran out of gas with ELM and flipped to PureScript, and then unfortunately PureScript is like very powerful, and that's like a whole age. It's like learning an entire new paradigm. So, but ELM is still a good route along that path. So let's have a look. So I think I did like an ELM init here. I can't remember how I got this. Did somebody send a link for this? How did I make this ELM project?
It was like a parcel quick start thing.
Oh yeah. It's a parcel quick start, exactly. And then I think I just changed some of the stuff here. So look how cool this is. Oh yeah, so parcel is actually very nice. It's a nice tool. It has native support for ELM, which is brilliant. So it means literally your project is like that. It's literally a Node.js project, and you just go parcel with some HTML file, and parcel, because it looks at your HTML, it goes, here you go, and it like wants to build all the dependencies, right? So it figures out that it needs to compile this index.js. I think in index.js, it then parcel reads this and it goes, you're using ELM. So like import ELM from source main.elm. So because it's like one of its dependencies, I'm not sure how parcel works exactly, but this is my understanding, is it tries to build all the dependencies and it goes, yes, okay, so I must fix that. I must like webpack the actual compiled ELM file into this index.js. And it just magically happens, which is really awesome. So So by doing that, I can go npm run start and parcel builds the thing, and then I can click on the little magical jobby and I get my Elm program. So that's tiny hello Elmy world, which comes from main.elm. So you can see it there. There's the import of main.elm. And then it calls main.elm.main.init, passes like a node in there. So I suppose it gets rendered inside an element called main. Probably if we go and look, you can see it there. So there's an HTML element called main, which index.js like runs the Elm program inside that element, if that makes sense. And then I didn't write any of this. This was part of the quick start. So that looks perfect. And then if we actually go and look at the Elm file, if we squint our eyes, we can kind of go, oh, okay, so there's a main something, and it is a div, and the div has got some text, which says, hello, Elmy world. It's like, oh, great, there it is. So that sort of works. And I suppose if I go view source or open this thingy, I can probably inspect this jobby, and I can see there's stuff going on here. There's a div, and it wrote into the div. Okay. Any questions there? That seems like we don't understand it yet, but like pretty simple. Yeah, you agree? So I thought what could be cool is, because we probably don't understand any of this, is like, should we go through this quickly? Like run through the Elm document. The Elm documentation is exceptionally good. It's very easy. It's been designed to be like any moron can learn this stuff. So I know if you go to elmlang.com, it even tells you. Oh, elmlang.com? Oh, .org, sorry. The most productive programming language I've ever used. No runtime, fearless, good. Understand anyone's code, fast and friendly, brilliant, great performance, small assets, interrupt, great. One of the hugely good things about Elm, though, is the documentation is exceptionally good. It's like written by a human in a very easy to understand way. And this is like these are like the tutorial or the guide. Okay, so the guide, so it takes you through a nice path of like learning everything about the language, like doing stuff, but in a very practical way. But then of course you can also find the reference docs somewhere. Elm references. Package.elm, is it there maybe? Elm syntax. I don't know. Elm packages maybe. Oh, packages.elm. Yes, okay. So then like if you want to get into detail, like you want to know what an HTML is or something, you can go and search that thing over here, and you can probably guess that it's in there. And like quite quickly, you can see these modules here. There's an HTML, and then you can like find the reference for each of these types and each function that's available inside each package. So like there's a package being imported called HTML. Exposing means exactly what it says. So when you import a package, you can choose to expose everything. So you could expose like everything, ... And that means everything is suddenly available inside this package, just if you just type it out. So like if you were looking at this strong or something, you could have strong available. I could go like strong, and like what is strong? I suppose I could go A equals strong or something. Hover over strong, and I can see, oh, strong is a list of attribute message to something to something. It's like, okay, yeah, it's just imported, right? It's imported this thing. It's just available as a function. So there's no real concept of like, actually, it's true of like most pure functional languages or Haskell type languages, that you often don't have this like this dot syntax thing. Is not often there. Often dot is there, but it's from a module perspective. So you could say, I want to import HTML as dog or something, exposing everything, and now suddenly I would have dog.strong, right? Does that make sense? So it's like there's a function called strong inside this module or package called dog, if that makes sense, right? So dot syntax often is like I'm looking through modules to find functions. There's no real concept of like an object has got methods on it or object has got functions on it. So you have to kind of unlearn that a little bit. If you're from like the C# or Java or object-oriented background, this dot thing is often just like looking up things in a different module or different package. So, and you can do it like that, right? So you'll often see stuff like import HTML as HTML exposing that, and then you would have for this div thing. Now div would probably not use import alias. Okay, nobody's using it, but why is div still okay? I don't know. I would then have to go like div.html.div, because we know div is a thing inside this package. It's not important that you know what div is yet. You probably do know what it is, but like div is a function inside this package called HTML, right? You happy with that? Kind of makes sense, right? So you import modules like that. So you can import whatever you want. And here's the package lists. Like there's lots of stuff that we can import. Okay, so that makes sense. So you've got the reference and the guide. I suppose that's the difference there. So we should probably keep the reference open actually. Let's keep it there, and we can go ELM guide again and open this guy, and let's carry on going through this thing. Okay, so the core. So maybe we should just like read this a little bit. Here's a program that lets you increment and decrement a number. Okay, I think this is probably a good place to start. Let's just like take this program and we'll dump it in here. Import browser. Is that not working? Import browser, module name missing. Oh yeah, I need a module statement. So at the top of each file, you should have a module main.
They just took it away.
Something like that? Yeah. So that was not in here, naughty, hey? So every file, like main.elm, every file should start with the thing declaring its module name and what it exposes. So exposing ... means it exposes everything that's inside of it. So if I had a value like age equals 10, because this is exposing everything, age is also being exposed to someone else who imports me. The same way they would import me exactly like this. They would go import main exposing ... and that would expose age directly into their like namespace, I suppose. But if you were a good Elm, if you were an OCD programmer, you would expose specific things here. You would say, oh yes, I want to expose main and age or whatever, like age. And now only age is exposed through this module. So anyone importing main would only see age. So it's like makes it like a public thing. And it doesn't have to be, and this is functions or data or whatever's, if that makes sense. But typically you expose everything, certainly if you're in main, kind of makes sense, right? Okay, so let's just check what this thing does first of all. So let's like press save, and I think this thing will just automatically reload. Does it? No, it doesn't. Normally it does automatically reload. It could be that I just broke it. So say I had to change this to minus and plus, and I press save. Yeah, okay, so it does like hot reload in the browser, which is super cool. There's also this funny thing that appears here, and you can click it and you kind of get this like debugger thing happens. There's kind of nothing going on in there yet, but we'll look at it later. So Elm, it's pretty, so Elm it was really the first language or framework to invent this notion of time travel debugging, which you now see in stuff like Redux, etc. So in fact, Redux copied Elm. Elm really came up with that idea of time travel debugging. It was really the first language. So a lot of its ideas have been stolen into other things, which is great, right? I mean, that's awesome. Okay, so let's try and understand what this thing does. So there's this line here, and we'll come back to it, but browser.sandbox thing, this is quite important. But let's start here. So what is this thing, first of all? So there's this concept of something called I don't know what to call it. It's got a few names, like an ADT, an algebraic data type, or often called a sum type. You might be familiar with something called an enum, right? So we know what an enum is, right? An enum is like a type with a name. So if this was in C#, you would go like enum. I haven't written C# for a long time, but I think you would say like enum dog, and then you could have different values of that dog. So it could be like poodle is a dog, comma, lab is a dog, right? Something like that. So an enum has got like a type name called dog, but the actual values of what that enum can be is either a poodle or a lab, right? There's no value called dog. Does that make sense? So, and technically, this is a sum type or an algebraic data type in C#. It's different to a class or a record or a structure which holds things. We can come back to it, but technically you could read this, you could squint your eyes at this thing called type message and say, well, it's an enum. You can say it's an enum, and it's an enum that's got two particular types of two values that it can be. Either it can be of type increment, sorry, it can have the value increment, or it can have the value decrement. But the type is called message. Does that make sense? So, and I can extend this. Typically, you would format it like a little bit differently. Would format it kind of like, so there's weird formatting rules with, I don't know why it's weirdly adding a strange new line there because I was trying to tell me something. And I could add increment, decrement, and do nothing or something. It could be the third option of this type called message, called do nothing. And now I've got compile errors for other reasons, probably because I'm not dealing with that the handling of it later. I'll hover over this unused pattern variable. Okay, yeah, not being used there. And this one, where is my error actually? Oh, I'm adding spaces. Oh yeah, so check out this. Here's an issue. I typically like use tabs by default, but ELM does not support that. We must use spaces. So let me just fix that. Convert to space. Otherwise, you do get wild and wonderful errors. So you have to use spaces. Is that true of Haskell too? I think it is. Yeah. And PureScript, you do need to use spaces. So in fact, it's the language is called, so you know, in other, like Python, for example, Python uses tabs. It can use tabs or spaces as long as you're consistent, I think. You can't mix them. And so it looks at indentation as saying this is scoped. These things are scoped together because they're at the same like indentation. That is true of this language, but it's a little bit better. So you actually call the formatting, the syntactic formatting in this language is not called indentation based, but you call it layout based. So it's based on how the code lays out in space is how the compiler will read it. So you can, with a layout based syntax, you're allowed to do stuff like that. As long as these things are at like generally the same level in the layout, then the compiler reads them as being at the same level, if that makes sense, right? Anyway, so it's like it's an odd point, but that's what type message is. Type message is a type thing, and it can have two potential values, only two, increment or decrement, nothing else. And it's an OR, right? So it's like a sum type, it's like an enum. Then we've got a method. This is a function. So functions are always like function, and then parameter 1, parameter 2 equals something. Parameter 1 plus parameter 2. That's how you declare a function. So the first thing is the function name. Spaces are kind of the same as brackets. So you can imagine that wherever you see a space, you can imagine an open bracket happening, and like a comma and a, you know, something like that. In this language, you don't need those because actually it's not. It's like obviously it's the function name, and then white space separates my parameters up until the point where I get to an equals, right? Like I don't need brackets to help the compiler parse that. It's simple enough. So that's how you write a function. So update here is a function which takes a parameter. The first parameter is called message, lowercase m. I think all parameter names have to be lowercase. All type names have to start with an uppercase, and all values of those types have to start with an uppercase. So I don't think I can go Tom here because Tom is a problem. I'm expecting to see a variant name next, something like success or sandwich, any name that starts with a capital letter, really. So it is an error to use a lowercase name. Lowercase names are specific to like parameters, if that makes sense. So parameters here also can't start with a capital. Does that kind of make sense? Happy with this? Yeah, so there's a lot loaded into this little line here. A function which takes a parameter called message and a parameter called model. Yeah. Then we go through this like case statement thing. And you can imagine it's the same as like a case statement in any other language. It's a lot more powerful, but we'll but read it like that. So it's like an if. So if message is equal to increment, then do this. If message is equal to decrement, then do that, right? Happy with that? Yeah, makes sense. And then you go like, okay, but what does it return? And in fact, look, there's a little warning here saying we are missing the type annotation for this function. I think I can actually just click on this thing. I click on exposed? No. I click on something and it can just write it for me. Quick fix. Add inferred annotation. There we go. So Visual Studio knows how to fix that. And you can kind of go like, so that is actually quite interesting because where is our model? Oh, there it is there. Yeah. Oh, so much to learn. So I think I could fix this by saying, I could be more specific and say it's an int to an int. The question is, what the hell is that? But right here, we're now being specific. So when we write a function, you can leave out the types. Oops. You can leave out the types. So I could go if taking an A and a B equals A plus B, right? So now we can leave the compiler to figure out what the hell the actual type signature of F is, because later we can say, well, A equals F of 1 and 2, and that's our issue. Then it's defined here again. What have I done? Matthew, you meant to help. Find over here again.
I think it's the A on line 17. I think it's gotten confused if you make it like X or something.
Oh yeah, that's weird, huh? That was confused by that A. Yeah, okay. So like here I've declared a function which takes two parameters, an A and a B, and you can quite clearly see that I'm going A plus B. So from that, if I hover over this thing, the compiler is like, it will work out the types underneath. It's going, well, it's got to be a number. It's a number and a number. So A is a number, B is a number, and that's probably because I'm adding them. Like when I use the plus operator, the plus operator is probably just defined for things which are numbers, right? And you can actually see this, but I'm actually hovering over A, which is awesome. And it says, yeah, A is the same as add, and add takes a number, and gives you a number. So the way you can read this is, this can sometimes, is anyone confused by that syntax? Some people I think will maybe be comfy, and others might be very uncomfy with that. Comfy, uncomfy. Put your hand up if you're comfortable with that syntax. Okay, so that's good enough for me. So effectively what this means is, it's really like the simplistic way of reading it is just like each of these things is like a comma until the last one. So literally, like if you have a C# or Java background, it's like it is add is, so this colon means is of type, that's what that means, is of type. So I'm declaring a thing and I'm putting its type annotation down. Does that make sense? So how would I do this in another language? I would go like, oh, add equals, what would I do? I would say, oh, add is a function that takes a, which is a, what do I go? Do I go like int a, comma, int b? I've forgotten how to write C#, guys. Is it like that? Return a plus b. Oh, sorry, I have to go int a. Is that right? Right,
yeah, it will just assume private
function.
by default.
Oh, private, yeah. Public int. Is that C#?
Forgot
Yeah.
a semicolon, but yeah.
Oh, semicolon.
We'll forgive that.
And this should be on the next line like that, eh? That's how Microsoft likes their functions. Is that correct? Yeah, okay. So you can read this thing exactly the same way. It's just more like terse, right? So it's like saying add is a thing. This thing means is of type, which is the same as like the whole freaking first line here. It's like you're giving the type signature of the function, right? And you're munging together two things. You're putting down the names of the variables as well as what are the types of the variables, and the name of the function and what is the type of the function, right? Or what is its return type, right? You're putting that all into this big thing up here called the signature. In an ELM or Haskell type language, you can separate these things out. You can say, here's the implementation of this function, which is like, hey, I get my parameters and I do something. So I've separated the A and the B. and the A plus B into the next line, and I'm giving the type information on the line above, right? So I go, okay, so f is a function which takes the first parameter is an int, the second parameter is an int, and what it returns is an int. So the last thing after the last arrow points to its like what it returns. Does that make sense?
Tom?
So in other languages, and I think other languages do this, where you see this like the return type of the function is often at the end there. Maybe
So TypeScript does that.
TypeScript
does it. There's a few other languages as well.
Yeah. So you often look for the return type here, and that's fine. Now look for the return type, over there. And so in this language, that's kind of how you can read it. So these little arrows. Yeah.
I just wanted to say, I mean, I think it's important, hopefully everyone's ready for it, is to point out that that arrow implies curry because it's int, or a curried function or something that only can take one parameter, right? Because it returns a function which takes an int which returns. So if you just change that public add of yours into JavaScript to return a function, because that's really what it is, right? Maybe that'll help the guys understand why. Because the curry for me, if I can explain a bit of my learning, is very important. In a pure functional language, every function must be a function that only takes one argument so that it can encourage curry, right? It's very important piece of functional languages for me, and that those arrows there start to make more sense if you think of it like the real way to read it is, f is a function that takes an int and returns a function that takes an int and returns an int. So there's two functions in there. Like
that. So f is, you're 100% right. So what Chart is talking about is this arrow is a little bit more complicated. It's not quite, it's okay in the beginning to go, f is a function which takes an int and another int, and it returns me an int. But the correct way of reading it would be to say, f is a function which takes an int and returns whatever's on the right side of the arrow, which is this thing. And it's like, well, what? Oh, sorry. And it's like, well, what is that thing? And it's like, oh, if you look at it, it's like, oh, it is also a function which takes an int and returns an int, right?
And it's important because now you can partially apply it. You can now partially apply it.
Yeah, absolutely. But that is the way to read it. So if you have a, it could be nutty, but let's make another function, which is takes three parameters. So let's go f, a, b, and c equals a plus b plus c. Now the type signature of this would be something that takes an int, takes an int, and gives us an int, right? But really the way the compiler reads this is like this. Insert the brackets. So it's like the first int, if I call f with one int, I get back a function which requires an int. When I give it that int, it will return a function from an int to an int. And when I give it that int, I'll get back an int. Does that make sense? So we can read this in JavaScript. Let's write this in JavaScript. We go f equals function, taking the a. And what does it do? It returns a function which takes a b. And what does it do? It returns a function which takes a c. And that function returns a plus b plus c, right? So that's exactly like one for one what it would look like in JavaScript. Does that make sense?
This was a proper aha moment for me, because at the beginning, when I was just reading these languages, I was like, it's just a fancy way to describe a function. But no, it's more than that. It enables it to be partially applied. I mean, you can't call that public add that you write there. You can't say, I want to call public add, but I'm only going to provide the A parameter, and later I'll provide the B. Can't do that. But the JavaScript next function, you can, because it returns a function that you can then later run with the rest of.
So you can always you can always, even in C# you could do it, but you would just write it in this horrible format, which would be like add is a thing which return. I don't know how to do this, but it's like, is there something like a func type
You
or something?
can,
Which
yeah, you can.
is an int to an int
Can't
or
pass
something
functions
weird.
around. Yeah,
And then I
yeah.
can return a,
It looks
you know,
horrible.
it looks horrible, yeah. So I'm going to delete it because it does look so horrible. But that's that's the advanced course on functions, is like every function only takes one parameter. So you might say, but I want both parameters, right? I don't want to be able to take only one parameter. I actually want A, comma B, and then maybe I want C or something like that. Like A and B are tied to each other. I want both of them at the same time. I don't want what chart is saying, which is like you can provide one parameter if you like. You don't have to provide this one, because if I provide that one, then I get back a function which gives me, the remaining function. And it's like you totally can do this because you've got the concept of tuples. I don't know in ELM actually, and someone needs to remind me of how you define a tuple in ELM. Do you remember, Matt? Is there a
I
tuple in
don't.
ELM? There probably isn't a tuple in ELM actually. I bet no,
think
there's
I've seen one. I think so.
tuple. I think it's
There
very
is.
cryptic.
And it's like that.
Say again?
It is like that. That is a tuple.
Like this?
Yeah.
I think that you can, but I think that it's incredibly. So if I go ELM REPL, do I get a REPL? Yes. So I can say 1, 2, and it's a tuple of two things. I think I can go 3, but I don't think I can go 4. Yeah. ELM is so fucked actually. Anyway, so tuples in ELM, and this is very common in ELM to find. It's very constrained. And why is it constrained? It's because the developer of ELM, the author of ELM, is very concerned with developer experience. So he's trying to create a language that is so simple that you can't even tie yourself in a knot with it. Like he wants it to be, because probably in his mind is, he says a tuple with 4 elements is like, it's not a good idea. You should rather then be creating records, and in fact, in his warning, which is brilliant, the errors in ELM are excellent. They're like, it's almost like a teacher teaching you the language, which makes it really easy to pick up. Is like, he literally says, I only accept tuples with 2 or 3 items. This has too many. I recommend switching to records. So he's saying, do this in a different way. Like, tuples are not good for things with 4 more elements. And it's like, well, that's maybe nice for you, Evan. He's the author of ELM. But I want 4 because I don't care if it's messy, right? And he's like, no, you can't. So, which is fine. So you can have tuples. Maybe you can have 1 element tuples, 2 element. Oh, you can't have 1 element tuples, 2 element tuples, and 3 element tuples. So if I wanted to do this with A and B together, like I don't want Chart's crazy idea, then I can just do that. I can say actually F, his first parameter is a tuple of 2 ints. And when you provide them, he will return this function. So the curried. So you typically just drop those brackets. If you love them, you can keep them. But now A is obviously a tuple, right? Does that make sense? So A there is no longer that first int. A is the tuple. So A is of type tuple int, comma int. And so you obviously can't plus this thing. That's where my error is there. And so I could take it out of its tuple by going, well, A, comma B, and then C and D there. So I could do what is called destructuring and destructure it as in the function parameters right there. But this is also a little bit advanced. Maybe not too advanced, but does that kind of make sense? So everyone's fairly comfortable. It can be foreign, yes, but are you comfortable with it? It's like, I understand this. I know how to read this now. Yeah, I think so. So we were busy reading what does the update function do. So let's get rid of these things. And now we can see, okay, so its first parameter is this thing called message, which we saw up there, which is like, okay, it's either our increment or decrement. The second parameter is an int, and that's interesting. And it returns an int. So the update function takes a message and an int and returns an int. And this is actually a little bit complicated. What we probably should have done is go and type model equals int. And rather than taking an int, we should rather take a model, right? I think. Model plus one. Addition does not work with this type. Model value is a model, correct? But it's, oh, sorry, I should have gone type alias there. Yeah. So this just makes this more explicit that my model is an int. We'll come back to this, like what is this model and message story? But now at least we can read the method. We can say, okay, update takes a message and a model and returns us a model. So you can kind of see this as like your update function in Redux, which would be called a reducer. Am I right? It's a reducer, right? You have that. If anyone's worked with Redux, you have to create those reducers, which is like, hey, I get given my like messages or things to, I think, are they your dispatched or your actions or something? Are they called actions? You get given your actions and your model and your state, maybe it's called, and then you have to describe how do you change the state and you return back the state. So you can imagine that update is exactly that. It's a reducer. And then we've got a thing called a view.
Picture. So there's a picture, I think you started on that ELM guide. There's a pretty cool picture somewhere under core language that shows you this loop.
ELM picture. This one.
Yeah, that one is basic, but then I think if you go to maybe HTTP there at the bottom, where it starts to talk about subscribers.
Oh, we get this thing, yeah. That one?
Not the one I was thinking of. Now I'll find it. I just thought the picture could.
So the basic model here is worth looking at this. The basic model is this. So you have your application is this here, and effectively, how does this actually work? So ELM is like the runtime. Is this your program? Yes, exactly. So your program is this ELM, and it produces HTML that gets rendered obviously to the browser, and any events created in this thing generates messages back to your program. So your program is just really one big update loop, which is like, hey, render this thing, and then whenever events arrive into the system, they are triggered as messages back into your program, which then describes how that HTML must be changed, right? So I mean, this is like
the model,
the basic,
right?
The basic loop, yeah.
Yeah, ELM takes a message and then decides how the new version of the model must look like combined with the HTML, right?
Yeah.
So in that blue little box there, it will adapt or change the model. Yeah.
And so you actually see it right here. This is that function. Update takes a message, so which is like the message coming in from the DOM or wherever, what your model looks like right now, and then what it must return is what the model, how the model changes, right? So this is the mutation happening from old model to new model. You get given the old model and you say, hey, what is the new model now? How am I changing the model? Then there's a function called view, which when given a model will describe how to render that thing as HTML back to the screen. So between these two functions, update and view, this one is changing the model and this one is just rendering a model. That is that loop. Does that make sense?
What helped me a lot is how is this important in the functional world? Because, you know, in functional, we don't want to mutate something. We don't want a variable that can sometimes be this and sometimes be that. And that is true for your whole application state as well, right? So what they do and what enables that time tracking is this model starts off with something you initialize. So there in that code Tom has opened, the initial model is just 0. Init equals 0 there at the top.
There, yeah.
And each update function would say, all right, I'll keep the state 0, but what's the new state? And it will append it to basically a list of states. And so the new state is actually now 1. And then we receive more input maybe from the browser and we decrement it, and then there's a new state. So now you can time travel through those states. You don't actually modify the state. You don't say, hey, let's take 0 plus 1 and now we have a new value for X or for the model. It appends it. It's the way Redux does it as well, which is an important concept for me, at least in functional, is we're not mutating it. So imagine you have one global JavaScript variable that you adjust. Why global is a bad idea if you're going to mutate the state, because you're never going to know what it is. But global is a good idea if you think of it almost like a Kafka commit lock, like there's just a new version and a new version and a new version. That's how I understood it. It helped me, I hope. someone.
Yeah,
Are you able
exactly.
to are you able
you
to
can
persist then? Like, can you go back and I mean, it's not really for this, but like, could you go back and see like 3?
Yeah. Let's go look, actually. So in fact, this one gives us a good example. So if I click the minus button, then my model. So if we look at what the view does, the view renders a thing called button with, and we'll get into this, and then a div with some text. And it's like, oh, look, it's just rendering the model as a string from int. Okay, so we can understand that. And then there's a button called plus. And so if we click plus and minus, we can see, oh, okay, look, our code over here is incrementing and decrementing the model, right, which is being written in over there. So now we can look at this little time travel debugger, click that thing open, and we can actually see the history of everything that's happened. And I can go, I can change, I can click on these events. I can actually see my view changing. So it's like we've got the entire commit log here. We started out here, and the first event, the first message received was decrement. Our model was 0, and the changed model became -1. Then we decremented again and again and again and again and again. And we can actually, as we click through it, we can see where we are in time, which is pretty cool. And it's totally deterministic. So, and I can press play again to go back to the current time, and I can carry on adding more events as I like here. So I could refresh this thing, and I can see a fresh new time travel debugger. And as I click plus, I see the event, increment, decrement, increment, whatever.
It's nice to quickly do like a user experience, like if you want to track user experience or journeys, what they've actually clicked on or what they've done. It's like cool. It's like it's there already.
Yeah.
And like Tom said, the deterministic element, if I understand correctly, Tom, is if I provide a model of 0 and a message of increment, the output's always going to be the same. While if you have like a state of variables, you don't know what the user did or what the state of the application was. So you don't know what the code actually did. But here you can always know that if this is the model and this is the message, this is going to be the output, right? Is that what you mean with deterministic, Tom?
Yeah. As well as the ordering. So the deterministic means that, in fact, if I have this function available to me and I know what message, so if I generate a history of these things, like I've got 5 decrement events or whatever, and I wanted to replay this one, all I would need to know is like what message was it? Oh, it was decrement. What was the model at the time? 4. And then I'm guaranteed that if I call update with that same message and that same model, I'll get exactly the same result, which is -5. So if that makes sense. So you don't actually have to keep the like state of the world around. You just have to keep in mind what were the messages, what was the message, and what was the model, and I can always recreate the model at any point in time. Does that make sense? So effectively, if you think about it in those terms, it's like I could start to think about how I can optimize for this thing. Like I could replay 10 events. I wouldn't have to remember all the interim ones, because if I knew what the events were along the path, all I'd need to remember is those events. I wouldn't have to remember the model all the time, because I could always recreate the model. You know what I mean? So you could think of it like this time travel debugger, although it sounds crazy, like maybe we're keeping the state of the world at every point in time. We don't actually have to. We just have to remember the state of the world at some point in time and all the events in between. And then I can recreate the state of the world at any point in time. Do you know what I mean? Because it's deterministic. Yeah.
That's interesting. This is scary close to Kafka.
Totally. Yeah, exactly right. Yeah. So you're 100% right, Bhavesh. 1000%. So when Chart says it's like a commit log, he's also in his mind has made the bridge out to like streaming or whatever.
Exactly. And that's why Tom chose Redux pattern to build on top of Kafka, because it fits very nicely.
Yeah, it fits this world perfectly. Yeah, exactly. And the cool thing is this language doesn't allow you to step out of the box. So I can't take model here, which we know is an int. It is like a syntax error. Equals is like a syntax error. It's like it can't even parse it. It doesn't know what equals even is. There's no way of mutating stuff. I can't say, oh, model is naught. There's no such freaking thing, man. I can't assign stuff. There's no such. The only time equals is like a valid syntax is when I'm defining a function. or I'm giving something a value. A equals 5. I can't go A also equals 10. It's like, what do you mean? It's not possible. A is 5 or 10. It can't be both. Do you know what I mean? So equals is like almost always an error. So does that make sense? And so what model is, I suppose like model is probably a bad name here. We should have called it like value or something. And then it's like, well, value minus 1 is a new int with the value minus 1, right? You know what I mean? So the kind of you can imagine that there's this implied word return here and here, but you don't need that because it's obvious. In fact, the word return is right up here, return, because case returns the thing underneath it. Anyway, there's no need to write the word return. A function can only have one thing on the left, on the right. There's no like this line then that line. There's no such concept. Like something has a value. That value could be a function. That's okay. You know what I mean? Functions can be our values as well, right? And that's what we're saying here. Update is a value, which is a function taking a message, which gives us another value, which is a function. Do you know what I mean? So there's no real distinction between a being an int here or update being a function. Like, in fact, they're the same thing. Does that kind of make sense? So that's why you would call this these are first-class functions. They're the same as a first-class citizen in the language, like a value or a variable, you might call it. And obviously, the word variable it's just a bad word because you can't vary anything. Like things can't be varied in an immutable language. So variable is the wrong word. You would call it a value, right? But value, in my mind, you can interchange it with the word variable that you would be used to in C# or Java or any other language, which are things that can be varied. You know what I mean? But variable, they're not variable, that's for sure. They're values. Yeah? Comfortable with that idea. So like this, so maybe we should just briefly look at this thing, at the actual view, because this thing is missing a type signature. Here we put the type signature and we haven't put one there, it doesn't matter. But view, like, let's write his type signature. Well, actually, let's ask this thing to write it because we learn a little bit here. Okay, so view takes an int, and it's because it knows it's an int because it's our model, but we could clarify this and say, actually, it takes the model. And because we've made our model just an int, but it didn't need to be. It could be like a complex record or something. We've made it just an int for now. And view returns an HTML. And like, here's something weird, right? There's no arrow between these two things. So it's like an HTML space message. So this should look a bit foreign. And the idea here is that this thing is really, I don't know what you would call it actually, in ELM, I don't know. In another language, you would call it like a container. You would use the word here of. So it would be like view is a function that takes a model and returns an HTML of message. Do you know what I mean? That's how you would say it, and it comes from, because it most often does sound like that. It's like f is a function which takes an int and gives me like a list of int. Does that make sense? And so here you would have list is like a container, and inside that container are ints. Does that make sense? So list of int. Comfortable with that, like at least how you would say it. So yeah, it's like a generic, right? So it is, absolutely. So it's a list which is specialized on types of int, if that makes sense. So here view is saying, I'm a function that takes a model and it returns back an HTML which is specialized on message. Do you know what I mean? So it's an HTML which has got like message inside it. It's of that type, not of any old type, but it's of that type. And it's like, oh, what is that type again? Oh, it's our type. It's our message type. So the way you can read this is you can say, oh, it's an HTML that when it generates events, they're going to be of that type, message. It's like, oh, makes sense now, right? HTML of event type message. So the HTML that's generated will generate us events. So if we think about it here again, remember that HTML is going to be rendered there. And when I click on shit, it's going to generate events. And it's going to generate these as messages into your program. what is the type of message? It's my type. So I could have written here like my messages, something. And let me just format that better so that I don't have crappy weird stuff. I could say, yes, I take my messages. It would be like, this would be an error now because it's saying, yeah, but there's problems here because of that. Sorry. It would say, oh, but your code, I couldn't find the message type. It's like, oh, yeah, because it's of my messages. And now we're good again. So it's like I generate HTML of my messages. So when this HTML that I'm producing below generates events, they will be of type my message, which is like, oh, perfect. Sorry, that needs to be fixed here. Does that make sense? So here I'm specializing the HTML. That's like from a syntax perspective, similar to generics. Yeah, it would be similar. It's basically generics. Yeah, you can think of it like that. Does that make sense? Because if we look down in the code, we can actually see that we have like so we have a div, we have a list, an empty list, and then a second list. Ignore that one for now. In this second list under div, we have a button, a div, another div, and a button again. And it's like, okay, this makes sense. You can imagine it's div. It's within the div, I've got a button and another div and a button. And within that div, I've got some text. Within this button, I've got this text. But then here we're adding something called attributes. So the first bracket after an element like div, if I hover over it, its first parameter, stay there. Its first parameter is a list of attribute messages. So they're attributes for the div. The second parameter is like a list of more HTML things. And it itself is an HTML thing. So it's like, oh, that makes sense. So it's like, it's got a list of attributes, and then it's got a list of other HTML things, which does make sense because divs do have that, right? So if I go div, I can go attribute equals 5. And then underneath it as a child, I can then have like a horizontal rule or something, right? So it's like, oh, so divs have got like 2 lists of things. The first one is its list of attributes, because I could have many. Attrib 2 equals 10 something. And then underneath it, I could have a list of children, like another horizontal rule, right? So those are the 2 lists. There's the first list for div, it's a list of attributes. And the second list is its list of children, which are the same as it, because these are full-on HTML type of thingies, right? Does that kind of make sense? So there's the first list. So div has nothing from an attribute. This first div has got no attributes. The second list are its children, which has got a button with an on-click something, and then a child, which is just text. So that's like saying we've got a div, and in there we've got a button, and we've got like on-click equals decrement, and then it's just got text, which is just like minus slash div. Oh, sorry, slash button, right? That's what that line is saying to us there. Button as an on-click decrement, and then just some random text with minus in it. So it's got no real children other than this one child, which is the magical text child. Does that make sense? You got that, right? Simple. Happy with that? Yeah. And so this type HTML of my messages is like, it's speaking specifically about these events here. So it's saying, well, what are the types that button could generate, or this HTML could generate? Oh, they're of type my messages, which is like, oh, on-click decrement. Does that make sense? Because decrement is of that type, my message. So everything's being type checked here. So make sure that you generate HTML that generates events that are of the correct type, that can be consumed by the update function. You can only ever get my messages, nothing else. It's not possible to say on-click generate like a string called Tom. You know, that would be weird. What is my error here? It's going to probably something be weird. This button call produces HTML of my messages, but all previous elements in the list are of HTML of type string. So it's like, oh, wait a minute. You can't just create a on-click Tom, because it's like you said, because this one doesn't work. So maybe I can say, well, this one also produces a mat. Now I'm going to have a huge problem here saying this div call produces strings, but the type annotation says it should produce my messages. So it's like, oh, good. Okay, there's there's an avoidable bug, right? Because in Redux, I could do this. On Redux, I could dispatch a string, right? And my reducer is expecting an object or something like that. Here, the compiler is checking this for me. Does that make sense? So I could even say, well, actually, my HTML does produce a string. And then it's like, that will now compile. Now we get some other compile error, which is probably similar. This argument is a record of type saying it's like view model to HTML string, but Sandbox needs the first argument to be HTML of my messages. So it's already saying, but oh, like up here, you're saying your update is, you know what I mean? Like the compiler's finding that mismatch. It's saying, yeah, your view needs string or produces strings, but your update function eats my messages. Like no comprende up here. Does that make sense? So like there is our compiler working for us, where we're saying, oh yes, all of our events must be of type this type. Are you convinced by the type safety yet? So it's like, technically it's like, you can't really get into a scenario where things are breakdown. So one other example is like, say for example, I generate some other kind of message like increment, decrement, and like a reset or something. Like I want a reset button, let's go and add it. Already here you can see like there's a compile error saying, wait a minute, missing possibilities, sorry, the case does not have all branches for all possibilities. So it's already checked, oh, you're checking for increment and decrement, but you don't have the reset case. And I would crash if I saw one of these. And it's like, well, why would you crash? And because someone's going to call update with reset on this model. And what are you going to return? Because you're not handling it. So you're going to return, like in the JavaScript world, if you did this, your function would return undefined. But that's not what you say you return. You say you're returning a model. So you're not allowed to not handle that case. So it's like, cool, let's fix it. So we go, well, if we get a reset, then value, sorry, I should just say, then value is 0. Sorry, my indentation's a bit screwy. That makes sense. And then it's like, we're good again. All the compile errors are gone. We're happy. We can go play with that tool again. And it's like, okay, cool. So we're handling a reset, but we're not generating a reset. So we probably need another button, which then sends us a reset event. And there he is. So we can minus click reset and we're back to 0. Yeah. And now here we can see the reset event coming in our time traveler. That make sense? We're out of time, dudes.
Went fast.
Thanks, Tom.
It was like baby wheels, web development.
I think Tom, in the next one can I had a question, but since we're out of time for the next one,
shoot it.
When you had the function in JavaScript that basically did the currying or expanded on the currying, I wanted to know, like in ELM and PureScript and Haskell and even JavaScript, like what is the order of evaluation? Like which gets executed first? Does it go from the first to the last, or from the most inner one back to the outer?
Oh, I see what you're saying. So it actually it only evaluates the one up to that. So your question is actually answered by talking through it. So if we go f equals a function which takes an a, and it returns, sorry, let's go like return function of b, and it returns a plus b, right? So there's like your most basic curried. So this would be the same as saying f takes an int and returns an int, right?
Yes.
So you're saying at what point is that evaluated?
Yes.
A plus b. Well, think about it. So if I call f, so I'm in JavaScript now. If I call f with a, then a gets executed. So it would return a function requiring a b. So the b is now f of a, and c equals b. Sorry, I shouldn't say b. Does that make sense? Like
yes.
fa, and then I can execute fa with b, and I get sort of fb. I don't know, something like that. So like technically you're going from an evaluate, the way you wouldn't in JavaScript be able to execute it. Like what you're getting confused with is like functions normally look like that, f1, 2, right? And you're going, okay, but I don't have the 2. So what happens to what evaluates here, right? And it's like, no, even in JavaScript, you wouldn't execute it like this. You would still have to go f of 1 and then execute that with 2.
Yes.
in order for it to be curried. So a curried function in JavaScript, executing a curried function looks like this. So it takes add, so the add function takes a 1 and a 2 and a 2. Looks like that. It's not.
Okay.
It's no longer 1, 2.
Yeah. Okay, that makes sense.
Yeah. So the comma is your issue, yeah, because you're saying, but something must evaluate because I'm executing a function, right? Yeah. So even in JavaScript, if you curry a function in JavaScript, it becomes like this. And when you execute a curried function, which is called partially applying it, it would look like that. That would be your syntax. So in ELM, that is already the case, because when I execute a function like this f here, it would be 1 space 2 space 3 space 4. So these things are functionally equivalent. Yeah.
Okay.
Yeah.
Okay, that makes sense. Yeah.
So it's not the same, not equal to f 1, 2, 3 like that. This is one. This is the first parameter to f. Yeah.
Happy.
So it actually only executes once you pass it the b. You know, that part of the code only executes once it gets its last parameter. Up until that point, it's just capturing parameters inside it. So they're being, like in language speak, you would call that a closure. This function is a closure because it's a function which takes 1b, but it's managed to somehow capture a into it. You know what I mean? So it's a closure. It's only languages that support closures can do this actually, because a technically, you know, if you put like lots of space around here and you return this thing, it's like, but what the hell is a? Like a isn't part of this thing. It's been like bound in from the outer function, which is magical, and that's called a closure. Not closure, but a closure, not closure, which is a language. Which supports closures. Closure supports closures also, but that's called a closure. Yeah. And so like old school languages like C did not support this. It might today, I don't know. I don't think C++ even supports this. No. So only fancy new languages support this closing in of A inside this thing. Because, you know, like you had this issue with, in JavaScript, you would have seen this a lot, like that equals this and shit like this, like these hacky things. And it's like, oh, I put this in here, or I put like name equals Miguel or something. And then like I can return a function which somehow talks about name in here. And it's like, yeah, but surely that thing belongs to this function. It belongs at that scope. And when you return this, surely it clears out all of this stuff. It must, you know, like must garbage collect everything that's in the scope of this outer function. And it does, yes, except for things that are referred to inside the function, inside functions that may have escaped. So there's like pointers back to things that it knows about. So when a function gets returned, there's a closure attached to it, which points to all of the things that that function could also still depend on, which were outside of its scope. And so it's quite complicated, actually. It's not a simple concept. But luckily, it's only a problem for language designers, not for us users, because it just makes sense to us, right? Hopefully I explained that. Okay, anything else? Yes, we've written the best ELM app.
That was very informative. Thanks, Tom.
Cool, guys.
Thank you.
Speak to you later.
Thanks, guys.
Go build the
Sweet.
Chuck
Cool.
Norris.
Thanks, everybody.
Cool.
Yeah, go build the Chuck Norris if you're brave. Charter and Matt have already. If you're keen, try, give it a go. I think like there's enough documentation for you at least to become frustrated with almost getting there. I think get to the point where it's like, I'm so close, and that's a good place to be.
All right.
Hey guys, have a
Cheers.
great day. Cheers.
Cheers.
Cheers.